Now let's look at another trig identity problem. There are several exercises in the homework where you are asked to prove or disprove an identity. And this is actually a trickier kind of problem because it means the given equation might be an identity and it might not be an identity. And you actually have to figure out whether it is or it isn't. So we're always going to take the following approach. Step one, we're first going to try to prove the identity. This is the same as verifying an identity, which is what we did in the previous video. If this works, you're done. So try to prove it. But step two, if step one does not seem to work, if we're not able to prove the identity, then the identity might be false, so we're going to try to disprove. And to do this, you do something totally different from proving. To show that an identity is false, you have to actually find a specific value of x that makes the two sides of the equation unequal, and you need to show this. So let's try this problem where we're going to prove or disprove 1 minus tan squared x equals secant squared. So it certainly looks like an identity to me. So step one, I might try to prove. Kind of looks like, reminds me of those Pythagorean identities we've already seen. Now to try to prove, I got to start on one side or the other. So it looks like, well, I'm just going to take the left-hand side. The left-hand side is 1 minus tan squared x. I can write that as 1 minus sine squared x over cosine squared x. And now, again, I'm just trying to see what I can do with this. I can try to add the 1 to the fraction with sine and cosine. To do that, I need a common denominator of cosine squared. I can rewrite that 1 as cosine squared x over cosine squared x. Anything over itself is equal to 1. And I'm using cosine squared because that's the denominator of this other fraction. So I have cosine squared x over cosine squared x minus sine squared x over cosine squared x. And now I can add these into a single fraction, cosine squared x minus sine squared x over cosine squared x. And, all right, now I'm kind of wondering what to do. Now I'm going to stop here on the left-hand side, and let's just compare to the right-hand side. The right-hand side is that secant squared x from our original equation. Secant squared is 1 over cosine squared x, so I can write it in terms of cosine. And so I have one side that kind of looks like this. I have the other side that looks like this. They both have the same denominator. These are equal only if, since the denominators are equal, they're only going to be equal if cosine squared x minus sine squared x equals 1. Now I know cosine squared x plus sine squared x equals 1, but there's no such identity with a minus sign, so I don't think so. Okay. So I think the identity is false. So we think the identity is false. And so we're going to move on to step 2 of the process. Unfortunately, sometimes step 1 is all you need and you're done. Here we think this might be false, so we have to pick a value of x to plug in. And it's not obvious what should be plugged in, and usually there's more than one value that might work. Here I just want to give you an example of, I'm going to pick x equals pi over 4. Pi over 4 is an angle where it's fairly easy for me to evaluate tangent and to evaluate secant, which is really just cosine, right? Now, I'm going to pick x equals pi over 4, and I'm actually going to plug it in to the original equation. So I have to take 1 minus tan squared x equals secant squared x. And when I plug in x equals pi over 4, I get 1 minus tangent of pi over 4 squared, I'll write that square with parentheses, equals secant of pi over 4 squared. And we're really asking ourselves, is that true? Because if it's not true with pi over 4, we do not have an identity. Now, we know tangent of pi over 4 is sine of pi over 4 over cosine of pi over 4, square root of 2 over 2 over square root of 2 over 2. In fact, the tangent turns out to be 1. So that left-hand side is 1 minus 1 squared, or just 1 minus 1, is going to be 0. The right-hand side is secant of pi over 4. Now, secant of pi over 4 is 1 over cosine pi over 4. So that's 1 over square root of 2 over 2. 1 over square root of 2 over 2 is going to be 2 over square root of 2, just the reciprocal of that, squared. And that's certainly not equal to 0. The right-hand side is actually equal to, that's going to be 4 over 2, which is 2, so that is not equal to 0. And what that means is, because we showed that the left-hand side is different from the right-hand side, when we plug in pi over 4, we have disproved the identity. And it's not an identity at all. And we're going to do one more of these. I think I will do it in a separate video.